Hello dear rockers. Today I'm explaining these operators in C concepts. Okay, we will move to the topic. Operators should index. So it means C supports so many logical blocks actually. Okay, we have to construct so many blocks. So on the for that reason, C supports 10 fundamental operators. The first one is the arithmetic type of the operator. Second one is the relational and equality. Then logical operator. Then unary operator. Then conditional operator. Next one is the bitwise operator, and another one is the assignment operator, then comma operator. The final one is the size of operators. Okay, we'll move to the first topic, that is the arithmetic operators. Arithmetic operator, the first one. Okay, it is used to execute the mathematical computational data. We can call it as the numbers also. Okay, especially numbers. That may be an integer, float, any data. Okay, so there is a so many operators. I will select any one of the board, this one and the white color. So many operators: the plus, minus, multiplication symbol and division symbol, and final one is the modulo symbol. The plus, minus, multiplication and division symbols are basic operational triggers. Okay, but the modulo, it will gives the reminder of the divisible numbers. Okay, so for first example, I will choose the plus operator. Okay, the in a plus operator, I have to find the sum of 10 plus 5. That will be stored into the sum variable. The same example I will take. Okay, the same example I will take. What is the sum of the 10 plus 5? That is the 15. 15 will be stored into the sum variable. This will be stored here. The 15 will be stored into the sum variable. The next one is the quotation. Okay, so 7 divided by 2 semicolon. 7 divided by 2 semicolon. The value is 3.5, but it's an integer value. These both are integer values, and the value I'm storing, that is also, that memory also stores the integer value only. So it's an integer division. So 7 divided by 2, answer is 3.5, but in a memory, and these two numbers are the integer numbers, it will only access the value that is 3. So 3 value, the answer is 3, will be stored into the quotient. Okay, and reminder, 7 mod 2. So what is the 7 mod 2 value is 1. The remainder will be 1, because when we are dividing 7 by using 2, so 2 2s are, sorry, 2 3s are 2 3s are 6. The remainder will be 1. The remainder answer is 1. 1 will be stored into the remainder variable. Okay, the next one is the relational operator. Okay, in a relational operator, we have to find the comparison of two variables. Okay, the comparison of two variables or comparison of two values, but always it will return the boolean value, that is 0 and 1. 0 or 1 value it will return. Okay, so when these conditions are becoming true, If the condition is true, then only it will return the 1. Otherwise, when the condition is false, it will return the 0. Okay. So we will check by using this example. The first one is int a is equal to 15. A contains the value 15 and b contains the value 10. It means a variable stores the value 15 and the b variable stores the value 10. Okay. So can I check by using the bracket? Because it's a two variables I'm using, that's why I'm using bracket. Okay. So a is greater than b. So a is a 15 is greater than 10. Yes, it's true actually. So this condition will always return the true. So it means it will return the value. The R1 will always going to store the value that is 1. So 1 is the answer. So the same condition is the same type of the another condition is also there, that is a is less than b. So a is a 15 is less than 10. Is it true? No, it's a false. The answer is false means 0. The 0 will be stored into the R2 variable. The R2 variable answer is 2, 0. Okay, 0, that is false. So another relational operator, that is greater than or lesser, greater than or equal to or lesser than or equal to we can use. So I will use only one variable, that is one kind of operator, that is greater than or equal to. Okay, greater than or equal to. So let me check. A is a, here I will choose this example. A is a 15, that is greater than or equal to 15 only. A is a 15, A contains the 15, that is greater than or equal to the same variable, that is 15. Is it true? Yes, it's a true actually. A is not a greater than 15, but it's a equal to 15. So that's why, so that's why, so A is true. True means 1. The R3 variable stores the 1 value. The same way, so true state held a value that is 1 and false state stores the value that is 0. So many symbols are there, that is greater than or less than, greater than equal to or less than equal to. And the next topic, I hope you understand these relational operators. And the next topic is equality operators. Now the equality operators, there is two equality operators. One is the double equal to, it means it's a double equal to. It will check the both side value is equal or not. Okay, both side value is a is a 10 and b is also a 10. So on that time, so these two values are equal or not, it will check. If it is true, it will return 1. If it is false, it will return 0. But there is another operator, that is a single equal operator. This is the assignment operator. Okay, this is the assignment actually, assigning operator. It means I'm storing some value, I'm storing this value into this variable. Okay, that's why this is the assignment operator. So you can check here, assignment symbol, that is the equal, with the comparison operator, that is the double equal. Okay, this is the double equal. There is a difference between these two equal operator, but in a equality operator, this assignment operator will never going to come. We have to work on double equal and not equal, this not equal operator. Okay, first we will check. Explicitly evaluates absolute matches or absolute mismatches between two operands. It means it will check the matches between two variables and the mismatches between these two variables not equal to b. So we can write this operator as a these symbols. Okay, there is no symbol in a keyboard like this, so that's why we have to use the not equal to symbols here. Okay. Okay, the first example by using double equal operator. For example, the int score is equal to 100. In a score variable I stored the 100 value. The value is 100. Okay, the check, I will check one, the variable that is equal to score. The score contains the 100. The score contains the 100 that is equal to 100. Yes, it's a true, so value stores 1, that is true. And checks the same, will checking if a score is 100, but I'm checking here that is not equal to 100. No, this is equal to 100. This is equal to 100. The not equal condition is wrong. That's why, okay, that's why the answer is 0. It will return the answer that is 0. Okay, I hope you understood this equality operator concepts. The next operator is logical operator. In a logical operator, there is a three main operators are there. One is the AND, the second one is the OR, and the final one is the NOT operators. Again, AND, OR, NOT. Okay. So when we have a two conditions, then only we are using AND, OR, and or operators. These two operators, when we have a two conditions, two different conditions, then only we can use the logical operators. And last one is the not operator is also there. When you have to check only one condition, so on that time, I mean, we need a reverse of the output of the that answer. So on that time only we will use the not operator. Okay, we will check the and operator example. So AND operator means when the value become true in both sides, then only it will return the true. Okay. So 5, just check this example. Check this example. 5 5 is greater than 2. Yes, it's a true. I can write it as a 1. So because this condition will return the true. The answer is 1. And means multiplication symbol, and the 3 is less than 1. No, 3 is not a less than 1. It means it will return the 0 value. So 1 into 2 is a, I mean, and operator answer is 0. 1 into 0, 0. 0 is the answer. It will always going to return the 0 output. Okay. When the one condition will become 0, I mean false, it will always return the false output only. Then the OR operator. OR operator means addition. Okay, addition. You have to remember, AND operator means multiplication. Okay, so if true at least one side, it evaluates the true. It means it returns the true answer. At least one condition should become true. Okay, so the same output, so the same example is here also. So 5 is greater than 2. Is it true? Yes, the answer is true. Plus, it means or symbol, or 3 is less than 1. No, it's a false. 3 is greater than 1 actually. So 1 plus 0, the answer is 1. And the final one is the final one example is the, I mean, not example, the concept is the not operator. This not operator, this is the inverse of this logical statement or a logical output statement. Okay, so What is the value? The value is greater than 5 is greater than 2. Okay, so what the output it will give? Yes, the 5 is greater than 2 is it will return the answer that is true. The 5 is greater than 2 only, yeah, that is true, but I have to return the inverse of this output. The inverse of the 1 is 0. Inverse of the 0 is 1. So that's why the inverse of the 1 it will return the 0. I hope you understood this logical operator concept. I will move to the next concept, that is the unary operator. Uh, yeah, the fifth concept is the unary operator. So operates on single operand to mutate value or state instantly. It means, so it will operate on only single value or single variable or single variable only. For example, this variable a have a value that is 10. So I want to increment this value. So a is equal to plus plus a. So the plus plus value always returns the a is a 10. So I'm pre incrementing this value. So that's why it means pre increment means I'm incrementing the value first. The answer is 11. And another value is also there, that is the post increment. This is the pre increment, and another one is the post increment. Okay, increment. The post increment means a plus plus. It means in the next condition it will increment the value in the next line, so not the exact line after executing this line. Okay, so the a value will remains same, that is 10 only. Okay, 10 only. When the a is 10, after this condition only it will return the 11. Right now in this line the answer is 10 only. Okay, when we are printing the a plus plus value. So we will move to the example. Before that we have to check the what are the conditions are there. The increment operator is there, and the decrement operator is also there, double plus and double minus, and the unary or minus operator is also there, that is minus. So we will check one by one. Okay, the first one is the x is equal to 5. So it means x stores the value that is 5. So I'm pre-incrementing this value, pre-increment. Okay, pre-incrementing this value, pre-increment here. So I'm doing the pre-increment here. Oh, so that's the reason x stores the 5. So 5 will be incrementing first. So x is becoming 6, and the 6 is stored into the variable that is y. So it means y is equal to plus plus x is there. So x is a 5. X is a 5. Okay. Suddenly in this line only x is incrementing. X is becoming 6 right now. 6 will be stored into the y variable. So y is also 6 and x is also 6 at this line, in this line. Okay, in this line. And next, and the next line is z is equal to x plus plus. This is the post increment. It means the next time it will be incrementing, not in this line only, not in this line only, in the program line only. So right now the x is 6 and y is also 6. Okay, so x is incremented. Just check, x is incremented. It's a post increment, but in this line x will never going to increment the value. Okay, x will never going to increment the value. Now next time x will be incrementing, not in this time. So that's why the z is a 6. When after this line, when we are printing print f percentage t comma x, then only the x value is this line will print the x value is 7, but the z value is always remains the same line value, that is 6. Okay, when you are facing the difficulties to understand this concept, please read the same video once again. Okay, especially this concept. Okay, once again you will be understanding better in better way. Okay, and the last one is the minus. So it's a very easy concept. When you have a x is equal to 5, just think int x is equal to 5. So when you have to convert this value into the minus symbol, so when you are using the minus x, sorry, so minus x, the answer is also become minus 5. That's it. Okay, so minus x, in the next line we have to write it as a minus x. So the when you are printing printf, the percentage, okay, percentage t comma, and the x value is it will return the minus 5 answer. Okay, when you are declaring the value like this, on the time it will return the answer like this. Okay, so when I'm clearing this x, so I can directly write the minus x here also. It will return the minus value, like how we are swapping in a max values or max signs. The same type we are changing the sign. The next condition is conditional operator. So this is the very important concept in the operators. So first in this place, so first I will explain the syntax. Okay, syntax. Okay, syntax is equal to, first I will write the condition. Actually this is the syntax, actually the condition. In the next place, question mark should be there. Question mark should be there. Okay, question mark should be there. In the next place we have to write the true statement. When this condition will become true, I have to print something, or I have to say something, that is it's a true value, like that I have to say colon. The next condition is false statement I have to print here, or false expression I have to print here. The final thing is the semicolon. So this is the syntax of the conditional operator. The first condition of the first expression is the condition. The next expression is the, if the value is true, then only I can print execute this statement. If this condition will become false, then only I will print the next expression. Okay, you can check here. I can call it as a ternary operator also in C. So many times we can call it as a ternary operators. You can in a bracket you can try write it as a ternary operator also. You can write. Okay, there is no difference. Conditional operator and the ternary operator both are same. And the practice example is integer type of the marks variable stores the 45 value. So here in a character result, I'm storing if the value is pass or fail. The marks is greater than, the marks is 45. The marks is 45. Okay, 45 is greater than 40. Yes, it is true. I'm questioning this condition. Yes, it is true. This part of the code will be run. Otherwise, when this condition will becoming false, this expression will be ignored and the final expression will be executed. So right now marks 45 is greater than or equal to, these marks 45 is greater than or equal to 40. So question mark, the condition this expression, that is the pass expression, will be run, colon, the false expression will be ignored. Okay, so it will run. This character will be stored into the result variable, that should be character data type. So right now the result stores the p. I will print the result, printf percentage c. I'm printing the character. The result is what? The variable is result I'm passing here. The result is I'm getting, that is p. P means it's a pass. Okay, this is the condition operator. It will work like this only. And the seventh one is the bitwise operator. So bitwise operator, it will most of the time operators directly on integer at their binary bit or bit individual bit layers. It means these bitwise operators works on the bits. Okay, bits 000 001 100 101, this type of the bits operators we are learning right now. So this bitwise operator will work on bits level value only. Okay, it means the individual bit values. So for example, unsigned character, it means I'm storing the value, that is 5. 5 will be converted into the unsigned character. Okay, unsigned character, that is 000. I will rub the previous one. This one I will rub. Okay, 000 0101. It means, I will explain you once again. 2 power 0 and 2 power 1, 2 power 2, 2 power 3, 2 power 4, 2 power 5, 2 power 6, 2 power 7, and 2 power 8, 2 power 9, like that. It will increment the value. So the first thing is 2 power 0. I have to store the value, that is 5. So 5, from here I will check 5 is the less than 2 power 7, but I will write the answer each and every 2 power values. 2 power 0 means it will return 1. 2 power 1 means 2. I will change the color also. Okay, 2 power 0 means 1. 2 power 2 means 2. 2 power 2 means 4, and 2 power 3 means 8, and 2 power 4 means 16, and 2 power 5 means 32, and 2 power 6 means 64, and 2 power 7 means 128. These all are the values. Okay, these all are the values of the two powers. Okay, now I have to check the phi. I have to write the phi by using binary numbers. So 128 is the greater number, so I will never going to take this number, and 64 is also greater than 5, so the value is 0, and 32 is also greater than, and 16 is also greater than, and 8 is also greater than. But from the left side, the 4 is less than 5, so I will choose this number. And 4 plus 2 is becoming 6. The 6 is greater than 5, so 6 is greater than 5. I will never going to choose this number, so 2 is 0 actually. And 4 plus 1 is 5. The 5 is that is equal to a 5, so that's why, so I will choose this number also. So 4 plus 1 is a 5. So this is the bitwise number. This is the bit or individual bit number of the phi number, of this phi number. Okay, so 000000101, this is the value of the phi. The same way, the value of the 3 is, the value of the 3 is, so I will choose here only 2 plus 1 is 3, so 1 1, all the values will remains 0 0. the same way we have to write for each and every numbers while converting number to bitwise number. Okay, I mean converting the number to bits. So for example, the 5, the number bitwise value is 0101, and 3, the bitwise value is 0011. Okay, so I want to use the AND operator, that is the bitwise operators AND, or XOR, and NOT. Okay, in a program we will solve all the operators. Right now I will explain only one or two operators. Okay, main operators. Okay, first I will choose the AND operator. Here I take an AND operator and example. So AND means I have to use the multiplication symbol. It means I have to perform the multiplication, okay, between A and B, between A and B. So A is a 1, 1 into 1. What is the output of the 1 into 1? So 1 into 1 is a 1, and 1 into 0, this one, the 1 into 0 is a 0, and this one, 1 into 1 is 1 into 0 is the 0, and all the other values are 0 into 0, 0, and 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 final one is the 0 into 0 and 0. This all are give the 0 output. So the by using bitwise operator, the result of the 1 and A and B is it will return the value is 1. And the left shift operator is also there. Left shift and right shift operator is also there. Okay, we will check the individual divide by left shift value. So left shift value means, first I will rub down all these things. Okay, yeah, now I will write the output here. So the value is A left shift 1, no? So what is the value of the A? 0 0 0. The value of the A is 5. 0 0 0 0 0 1 0 1. The value is 5. So this is the bitwise values. These all are the bitwise values. Okay. Okay. So it means the left shift I have to use this condition. I am using the left shift. Okay. It means left shift 1 means always okay. I put the box here. I mean table here. I have to left shift each and every number. First one is the this number, this A number. I'm left shifting. I'm shifting it into the left side. So I will use the. I'm shifting this number into the left side. So 1, and this number here 0, and this is the 1 I will shift here, and 0 will be shifted 0 left, and 0 also shifted left, and 0 also shifted left, this 0 also shifted left, and this 0, the final 0 will be deleted. Okay, so and here in this empty place I will put, always we will put the 0 value here. Okay, 0 value, not 1, 0. So the left shift of the A left shift 1, yeah, the output is 1 0 1 0. So when we are applying it into the this table 2 power 0, so 1 1 0 1 0 means in these two places there is a 1. So the fourth place and the second place, the fourth place value is the 8, and the second place value is the 2. So 8 plus 2 is a 10. The left shift of the A left shift 1 is, the output is 10. I hope you understood the same thing. Same thing will be repeated to the right shift also when we are applying the right shift also. So this will also give the same type of the output. We will move to the next concept, that is the assignment operator. This is the very important concept in us when we are working on coding, if else and conditional statements. On the time, this is the very important concept, that is the assignment operators. Okay, so many of assignment operators is there. Mainly we are working on equal, plus or equal, and minus or equal. So many operators are there. One is the equal, the next one is the plus or equal, and another one is the minus or equal. Next one is the multiplication or equal, and the last one is the division or equal. So all these operators are there. We will learn one by one. Okay, so only few example I will discuss here. Remains are same, the same output, I mean the same syntax it will follow. Okay, that's fine. The first one is the equal operator, assigns y directly to x. Okay, it means y value will be stored into the x variable. So for example for example x is equal to 10. So directly x stores the value that is 10. Yeah, x is equal to 10 means in x variable memory location the value 10 will be stored here in x memory location. That's it. And the x plus or equal to y, it means the abbreviation of this x plus or equal to y means x is equal to x plus y. It means x is repeating two times. Again, it means x is equal to x plus y. The x plus y value will be stored into the x location only. So the x is 10 right now. The x is here. The x is 10 right now. I will explain here only. X is equal to 10, this 10. Okay, x already stores the 10 value. 10 plus, I'm adding some more some another value, plus or equal to 5. 5 means plus 5, the answer will become 15. The answer of the is plus or equal to 5 means the answer is 15. Next, the same way, right now x stores the value that is 15. Okay, x is equal to 15. Right now x stores the value that is 15. Here also I will change the value that is 15. Okay, so x, that is x multiply or equal to y. So it means the abbreviation of this expression is x into x is equal to x into y. So what is the answer? So yeah, right now x is a 15. 15 into, so y value is 2. 2, 15 to the 30. 30 will be stored into the x location. The same way all another operations will be performing, multiplication, division, and all operations. The next concept is the comma operator. Act as a separator and a sequential equation operator. So it means comma always act as a separator and the sequential operation it will perform. Okay, it will act as a sequential operator also. So we will check one by one. Okay, evaluation sequence operates strictly from left to right. It means when we have a comma operator like this, it will always works from left to, okay, left to right. It will perform these operations. First a variable, x variable will be created. Next y variable will be created. Next val variable will be creating. So one by one variable will be creating. Okay, the next one is the returns parameters, evaluates and returns the final rightmost expressions. It's okay, we will check how it is. The one variable will be created, that is the val, by using that is the integer variable. So I'm storing some values. So x is equal to 3. It means x stores the value that is 3 first in first step, and y stores the X stores the value that is 3 in this first step, and the second step the Y stores the value that is 5, that is 5. So it will work like this: X is equal to 3 and Y is equal to 5, and the next value is, and next one is the X plus Y. X plus Y means X is a 3 plus in this final the evaluate result. Okay, X plus 3 and X is a 3 plus Y is a 5. The answer is 8. 8 will be returned to the variable that is value. It will always going to return these two condition when it was returning the value. Okay, these two conditions. It will never going to store the value in X and Y variable only. It will store the value in a variable in this variable memory location. That's it. The comma operator is completed. The final one is the size of operator. Always we have to check the size of the memory location. That's why we have to use the size of inbuilt functions. Okay, the inbuilt function is small letter size of these two brackets we have to use. In the between these brackets we have to mention the variable name. Okay, variable name we have to mention. Okay, name we have to mention here between the uh, size of inbuilt function. Okay, first I will check the bitwise character, sorry, byte character, byte char memory location I'm storing. I mean the byte of the character. How I have to check how many bytes are there. So the size of character will always going to return the bytes values. So it means the character, the integer have a 4 bytes, and a character have only 1 byte, stores the only 1 byte memories. Okay, I mean memory values. And next one is the float is also a 4 byte, and the double is a 8 byte. Okay, right now here the integer value, integer data type, the byte character stores how many values? The size of char stores only one value, I mean 1 byte, and the size of int stores the 4 bytes, and the size of float stores the 4 byte, and the size of double stores the 8 byte. It will print the value like this. Okay, this value will be stored like this. I will write the another example here, don't worry about it. Okay, I will write the another example here. Int a is equal to 10 semicolon. This is the integer type of the variable I created. The value is a 10 value I stored here into this a memory location. Okay, so whatever it is, the when I'm creating the integer type of the variable, it will always going to store the create the 4 byte of the memory location. So 4 byte means 1 byte means 8 bits, 4 byte means 2 power 4. 2 power 4 means 16. Okay, I already explained here 2 power 4 means 16. Okay, so 16 memory location it will take. Here only 2 power 4 means 16. This much of the memory location it requires: 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 and 16. Okay, 16 memory location it will take. So in this 16 memory location only I will store the value that is 10. So when I'm converting the 10 into the bitwise operators, I mean bitwise numbers, so 10 is a, I will convert the value 1 0 1. So 2 power 0, 2 power 1, 2 power 2, and 2 power 3, and 2 power 4. So it means I will rub the values here. So I have to rub the values. This is the wrong. Actually wrong. Okay. So 2 power 3 means 8. 2 power 3 means 8. 8 plus 2 power 1 means 2. So 8 plus 2 is 10 actually. So others will remains 0 0 0 0 0 0 0 0 0 0. So this is the memory of the 4 bytes. Okay. So 16 memory location will be created to power 4 bytes. Okay. 4 byte is created. Now here, from here I'm checking the size of a. I have to print this size of a. Okay, I will use the two brackets and print f. The size of a is a, what is the size of a? The size of a is 4 bytes. The size of a is 4 bytes, and I have to print this 4-byte value. That's why I have to use the percentage d symbol, percentage d. Okay, so then only this size of a value will be written into the percentage d, that is the format specifier. I'm printing this 4 value by using printf function. The same way, each and every character, each and every data type stores some number, some bytes of the value that will be printed by using size of operator function. Okay, that's it. Thank you for, I hope you understood this complete session, the operator concepts. If you have any doubts, please put the comment. I will try to clarify your doubts. Okay, and please subscribe my channel for more updates. Thank you for learning.